Let's model the energy usage of our dune buggy. We'll assume that petrol, 10 gallons or 1600 megajoules, is used for two things: running the engine at a fixed rate of 50,000 joules per second, and also overcoming resistive forces of F equals kV squared, where K is a constant and it's equal to 2.5 joules second squared per meter cubed. So the total power required is P is equal to FV plus E, or, substituting this in, the total power required is kV cubed plus E. The available power is equal to the total amount of energy available divided by T, where T is the total journey time. And if T is the total journey time and V is the velocity, then the total journey distance is x equals vt. So we want to work out the maximum distance we can travel and the speed we should go at to get that maximum distance. So what we do is we combine this equation with this equation and this equation, and it will give us x in terms of v. So when we combine them, we get 1600 megajoules divided by t, which is equal to x over v, and that's equal to the expression for the power, which is kV cubed plus E. And so we can rearrange that to make x the subject, and we get 1600 times 10 to the 6 times v divided by kV cubed plus E. So now we've got an expression for x in terms of v, and the graph of that looks something like this. So if we plot v on the horizontal axis and x on the vertical axis, this expression looks like that, and you can see that we've got a value v for which we get a maximum distance. So how do we work out these two numbers? Well, we've got a maximum, a turning point. So what we need to do is differentiate x with respect to v and set it equal to 0. So to differentiate this expression, we need to use the quotient rule. So let's get the constant at the front first, 1600 times 10 to the 6. And then the quotient rule is the bottom, which is kV cubed plus E, times the derivative of the top, which is 1, minus the top, which is V, times the derivative of the bottom, which is 3V squared K, all divided by the bottom squared, so kV cubed plus E all squared. So we've differentiated it, now we need to set it equal to 0. So when dx by dv equals 0, it's the same as this expression being 0. So that's kv cubed plus e minus 3v cubed k equals 0. So we can rearrange that and get an expression for v. So when we rearrange it, we get v is equal to the cube root of e over 2k. And we have numbers to put in now. So we have e is equal to 50,000. We've got k is equal to 2.5. And when we work that out, we find that our optimal v is equal to 21.54 meters per second. So that's here. V is equal to 21.54 meters per second. So we're not really after the driving speed as much as how far we can go on that optimal driving speed. So we just need to put our numbers back into our expression for x. So we get x max is equal to 1600 times 10 to the 6 times by v, which is 21.54, divided by k, 2.5, times 21.54 cubed plus e, which is 50,000. When we put the numbers in, we find that our maximum possible distance is 460,000 meters, which is 460 kilometers.